The Himalayas, home to the world's highest peaks, seem unshakable, but their story is anything but simple. These mountains are still rising inch by inch, a reminder that our planet is alive and always changing. The Himalayas shape weather, feed rivers, and support millions of lives. For years, we thought their foundation was simple: two massive landmasses colliding. But new discoveries reveal a far more dynamic and surprising foundation. The ground beneath the Himalayas is not just stone, it's a living, shifting system. The question is no longer just how the mountains formed, but how they continue to stand. The Himalayas are not just a monument to the past, but a window into the restless heart of our planet. The classic theory, India, once an island, crashed into Asia 50 million years ago. The Indian plate slid under the Eurasian plate, pushing the land up to form the Himalayas. This process, called subduction, was thought to create a thick, strong crustal root, like a tree's deep roots anchoring the mountains. For decades, this model made sense. Thick, buoyant crust floats higher, forming towering peaks. But as scientists studied earthquake patterns and mountain deformation, questions emerged. Was a thick, rigid crust enough to explain everything? New technology allowed us to look deeper, revealing a more complex story. The simple collision model couldn't explain all the evidence. Something unusual was happening beneath the surface. To truly understand the Himalayas, scientists needed to see through solid rock, down to the planet's hidden layers. The journey to the real answer was just beginning. The old model was elegant, but reality is far more intriguing. What lies beneath is not just strength, but surprising flexibility. Recent discoveries have upended our view of the Himalayas' foundation. Scientists found that the Indian plate is peeling apart as it dives under Asia. The lighter upper crust scrapes off to build the mountains, while the denser lower crust sinks deeper. This peeling leaves a gap filled with hot, soft, flexible rock, more like a slow-moving fluid than solid stone. Imagine the mountains resting on a giant trampoline. The surface bends and flexes but still supports the weight. This trampoline effect means the Himalayas are supported by a dynamic, buoyant layer, not a rigid block. It explains why the mountains are still rising and why earthquakes behave unpredictably here. The flexible layer changes how stress is distributed, affecting where and how earthquakes strike. This new model also solves old mysteries, like odd gravity and heat patterns around the Himalayas. The discovery shows that mountain building is not just about collision, but about peeling, floating, and flexing. The foundation is alive, constantly shifting beneath our feet. This insight transforms our understanding of how the world's greatest mountains stand tall. The Himalayas are balanced on a foundation that's as dynamic as the forces that created them. Science is rewriting the story of these giants, and the implications reach far beyond the mountains themselves. How did scientists uncover this hidden trampoline? They used seismic tomography, like an X-ray for the Earth, tracking earthquake waves with hundreds of sensors. These waves move differently through solid and soft rock, revealing a 3D map of the deep Earth. The result? A vivid picture of the flexible layer beneath the Himalayas. This knowledge is crucial for millions living in this earthquake-prone region. Understanding the true foundation helps predict where stress builds up and where earthquakes might strike. It's not just science, it's about saving lives and preparing for the future. The Himalayas remind us that even the mightiest mountains rest on restless, surprising foundations. As we listen to the Earth's heartbeat, we discover that our planet is full of secrets, waiting to be revealed. The story of the Himalayas is a story of curiosity, discovery, and the ever-changing Earth.